Hey everybody, and welcome back to MathPastor as we conclude our module on factors, fractions, and exponents. Hey, the final topic we need to talk about is scientific notation. All right, we've talked about a lot of things. We're gonna complete this module by talking about scientific notation. Well, what is scientific notation? Well, scientific means it's used in the sciences, and notation means a way of writing something down. So scientific notation is how really big numbers and really small numbers are written down in some fields of science. So when we're talking about the distance between planets or galaxies, that might be written in scientific notation because it's a really big number. Or if we're talking about the size of a cell in a membrane, then we're talking about really small numbers, or the size of a dust mite, or the time it takes light to travel just 1 meter could be a tiny, tiny fraction of a second. Those can all be written in scientific notation. It's just a way of writing really big or really small numbers more easily. All right, so scientific notation is based on the powers of 10. And the reason it's based on the powers of 10 is because when you multiply by 10, you simply move the decimal point to the right one place. And when you divide by 10, you simply move the decimal point to the left one place, making it bigger or smaller respectively. So any number is scientific notation if it's written in this form: a times 10 to the n power. Any number a, as long as a is between 1 and 10, so it's more than 1 but it's less than 10, times 10 raised to the n power, which can be any number, positive or negative. It's an integer, it's always a whole number. All right, so when we look at scientific notation, we want to make sure first that the number in front, we're calling it a, is between 1 and 10. If it's not between 1 and 10, then it's not written in scientific notation. So, for example, 12.1 times 10 to the second is not written in scientific notation because 12.1 is not between 1 and 10. It's more than 10, so it doesn't qualify. Instead, we'd have to write it as 1.21 times 10 to the third power. So we've moved the decimal point over one place, so we added 1 to the exponent. And now 1.21 is between 1 and 10, so it is written in scientific notation. All right, in this section, we're going to talk about 3 different skills. First, the first one we already talked about a little bit, is a number written in scientific notation? That's a yes or no question. And then the second one is converting between the standard form of a number and scientific notation. So taking that really big number and putting it in scientific notation, or taking that scientific number and writing it as that really big or really small number. And third, we're going to talk about multiplying numbers that are written in scientific notation, which is actually going to use some of the skills we learned in earlier videos. All right, so let's talk about scientific notation, whether something's written in scientific notation or not. All right, n, the exponent of 10, can be positive or negative. If n is positive, we're talking about a big number, a number bigger than 1. If we're talking about the exponent being negative, that's going to make the number really small. So we're going to move the decimal point to the left, and it's going to make the number really small. Here's a couple examples. All right, here are 2 ways or 2 examples for writing standard form in scientific notation, and we'll talk about going backwards as well. So first, our first example is 9,250,000. That's a really big number. So if we look at this, 9,250,000, we need to make this number be a number between 1 and 10. So I'm going to put the decimal point after the 9, between the 9 and the 2, because 9.25 is between 1 and 10. And if I do that, I have 1, 2, 3, 4, 5, 6 places to the right of my decimal now. So this number, 9,250,000, can be written in scientific notation by doing this. 9.25 times 10, and since we moved 6 places, we're going to make it to the 6th power. So 9.25 times 10 to the 6th power. They're taking a really big number and writing in scientific notation. We can also use scientific notation to talk about really small numbers. So here's a really small number. It is 0.0000057. So I have 5 zeros before the 57. Now, if I want to write this in scientific notation, I need to move the decimal point so that I have a number between 1 and 10. So that means the decimal point has to be moved between the 5 and the 7 because 5.7 is between 1 and 10. All right, if I move the decimal point that many places, from where it was to where it is now, between the 5 and the 7, I'm actually moving the decimal point 1, 2, 3, 4, 5, 6 places. And since I went from a small number, I know that I'm going to have a negative exponent. So 5.7 times 10 to the negative 6 power. So when I move my decimal point to make the number from a really small number up to between 1 and 10, the exponent is going to be negative. When I take a really big number and move my decimal point so it's a number between 1 and 10, I'm going to have a positive exponent. So positive exponents represent really big numbers, and negative exponents represent really little numbers. Of course, we can work this backwards as well. If we see a number written in scientific notation and the exponent is positive, that means we're going to take the decimal and move it to the right that many places. If there's more places than there are numbers written in scientific notation, I'm going to fill in those values with 0. So let's look at our example we just did. 9.25 times 10 to the 6th power. I'm going to take that decimal between the 9 and the 2. I'm going to move it right 6 places. And as you can see, I've moved it more places than I have numbers. So I'm going to fill in those with zeros. So 9.25 times 10 to the 6th power brings us back to 9,250,000. I can also do this with small numbers as well. If the exponent is negative, I'm going to move the number to the left that many places. So if the exponent is 10, I'm going to move the decimal point 10 units to the left. And anything that is empty, I'm going to fill in with zeros. So I'm going to end up with 0 point something, and usually it's going to be 0.000000, and then my number. So for our example we had a moment ago, 5.7 times 10 to the negative 6th power, I'm going to move the decimal point 6 units to the left. I'm going to fill in those zeros. So now I have 0.00000057. All right, finally we're going to talk about the skill of multiplying numbers written in scientific notation. Now it's going to look really difficult, but it's actually pretty simple. All right, here are two numbers written in scientific notation. I have 6 times 10 to the 5th, and I have 9 times 10 to the 7th. Now, I'm going to take the numbers, 6 and 9, I'm going to multiply those together to get 54. Then I'm going to multiply the numbers with a common base. The base is 10. So 10 to the 5th times 10 to the 7th, I'm just going to add the exponents. That gets me 10 to the 12th power. So when I multiply these, I end up with 54 times 10 to the 12th power. However, 54 is not between 1 and 10. So I need to insert a decimal point between the 5 and the 4. And since I moved the decimal point 1 unit to the left, I need to add 1 to the exponent. So 54 times 10 to the 12th becomes 5.4 times 10 to the 13th. So when I move the decimal point, I got to change my exponent. So 6 times 10 to the 5th times 9 times 10 to the 7th becomes 5.4 times 10 to the 13th power. All right, you guys should be all set to tackle any problems that pop up in a textbook dealing with scientific notation. Good luck.